Question 433. There is 4 feet by 4 feet square cardboard. Justin wants to make an open box by cutting a square from each corner and folding up the sides. What is the dimension of one side of the box to have the maximum volume of the box? Okay, here we have a 4 feet by 4 feet square cardboard, and Justin wants to make an open box by cutting square from each corner. So we are cutting 4 squares here, right? Okay, and he's gonna fold up the side. So he's gonna fold this size to make an open box, right? Okay, let one side of the square cutting be x. Okay, so here we have x. Then the side of the base of the box will be 4 minus 2x, right? Here we have 4 minus 2x. Does that make sense? And we're gonna make open box that looks like this, right? Okay, the height will be x, and the base, that's a 4 minus 2x, 4 minus 2x, right? So good. Now let's write the equation of the volume of the box. So volume of the box, B, is equal to, it's a base times height, right? So base 4 minus 2x times 4 minus 2x times height, x. So we have 4 minus 2x squared times the height, x, right? As you see already, this equation is in one variable equation, one variable x, right? So what we can do is we can just differentiate this equation with respect to x, right? Okay, so v prime x is equal to, since this is 4 minus 2x squared times x, we're going to have to apply the product rule. So derivative of 4 minus 2x squared, that's 2, 4 minus 2x, times derivative of 4 minus 2x, negative 2. And we have x plus 4 minus 2x squared times the derivative of x, 1, right? So now we have a 4 minus 2x here, 4 minus 2x here. Let's factor this. 4 minus 2x times, here we have 2 times negative 2x, that's negative 4x, plus we have one more of 4 minus 2x, because we had a 4 minus 2x squared, right? So that's going to be 4 minus 2x. So far so good. So that is equal to 4 minus 2x times, that's going to be 4 minus, negative 4x minus 2x. That's negative 6x, but we have a 4. So 4 minus 6x. And let's factor 2 from this expression. 2 times 2 minus x. And factor 2 from this expression. 2 times 2 minus 3x. So v prime of x is equal to 0. Let's rewrite v prime of x is equal to 0 when x is equal to 2 from this expression right here, and 2 over 3 from this expression, right? So x is 2, or x is equal to 2 over 3. So far so good. Okay, can we have x is equal to? No, right? If x is equal to, the dimension of base of the box would be equal to 0, right? So we cannot have x is equal to. What about 2 over 3? Yes, we can have 2 over 3, right? 4 minus 2 times 2 over 3 is not equal to 0, right? Okay, let's test this. Here's the x. Here's the 2 over 3. Let's say x is equal to value less than 2 over 3, maybe 1 over 3. Let's say this is 1 over 3. If we substitute 1 over 3 here, 1 over 3 here, 2 minus 1 over 3, positive. 2 minus 3 times 1 over 3, that's positive, right? So we have a positive here. And if we substitute, I guess, 1 here, then 1, 1, that's going to be positive, negative. So negative, right? So volume increases up to this value right here, and then decreases. Like that, right? So we'll have maximum volume when x is equal to 2 over 3. And the question was to find the dimension of one side of the box, right? So one side of the box, which is 4 minus 2x, is equal to 4 minus 2. X is 2 over 3, right? 2 over 3 is equal to 4 minus 4 over 3. So that's going to be 12 over 3 minus 4 over 3, 8 over 3. So our answer must be 8 over 3. Okay? Question 435. An isosceles triangle with the legs 4 inches and vertex angle theta is given as above. Find the angle theta that maximizes the area of the triangle. And triangle is right over here. And we are looking for the angle theta here that maximizes the area of the triangle, right? So we're going to have to write the equation of the area of the triangle. Area of the triangle is always equal to 1/2 times base times height. And we're going to let this side be base of this triangle. So base times height would be then from here to here, right? This is right angle. That's going to be height. So height, right? Okay, so this is equal to 2h, right? Area is a 2h. And we have to write h in terms of theta, right? So that we can find the angle theta that maximizes the area of the triangle. So far so good? Here, this is right triangle, right? So if we use the trig, sine theta is equal to opposite. Opposite is here is the theta, okay? Opposite is h over hypotenuse 4, right? So h is equal to 4 times sine theta, right? So substitute 4 sine theta here. Then our area is equal to 2 times 4, 8 sine theta. One variable equation, right? So now let's differentiate this equation with respect to theta. So a prime theta is equal to 8 times the derivative of sine, that's cosine, right? Set this is equal to 0, right? And we're going to have to find the critical point. Cosine theta is equal to 0 when theta is equal to pi over 2, right? Okay, so our area, well, the derivative of area is equal to 0 when theta is equal to pi over 2. So let's test this. Here's the theta, pi over 2. Well, the angle has to be greater than 0, and it has to be less than pi, right? So a prime here. So if we substitute angle that is less than pi over 2, let's say pi over 6 or pi over 3, whatever. Okay, if theta is equal to pi over 6, then 8 times cosine pi over 6, that's positive, right? If we substitute, let's say 2 pi over 3, if we substitute 2 pi over 3. Then cosine 2 pi over 3. 2 pi over 3 is in second quadrant, right? So cosine is a negative. So here we have negative. So area is increasing up to this point and then decreasing after that, right? So area of the triangle is a maximum when theta is equal to pi over 2, right? So the answer is equal to pi over 2, right? Question 441. A right circular cylinder has a volume of 32 cubic inches. If the cost of the material of the cylinder is $4 per square inches, what should be the radius of the cylinder to minimize the cost of building the cylinder? Here we have right circular cylinder with a radius r and height h, right? And it says volume of the cylinder is 32 cubic inches. So we can write the volume, which is base times height, pi r squared times h, that is equal to 32, right? If the cost of the material of the cylinder, the material of the cylinder has to do with the surface area of the cylinder, right? The cost is $4 per square inches. Then the question is, what should be the radius of the cylinder to minimize the cost of the cylinder? Okay, let's write the area, the surface area of the cylinder. Remember, this is from geometry, okay? If we unfold this cylinder, we will have two circles, right? Let me draw with a small picture. Two circles here and one side. So the area of two circles is going to be 2 pi r squared plus, the distance from here to here, that's the circumference of the circle, right? 2 pi r, right? The height of the cylinder is h. So the area of this rectangle is 2 pi r h. 2 pi r h, right? Now what's our cost? Our cost to C is equal to 4 times the area of this, right? So 4 times 2 pi r squared plus 2 pi r h. So far so good? Okay, now when we look at this equation right here, we have two variables here, right? R and h. So we're going to have to make this equation in one variable. Here it is given that volume pi r squared h is equal to 32, right? So we're going to use this equation. Here, let h is equal to 32 over, well, h is equal to 32 over pi r squared, right? If we solve for h in terms of r, substitute this expression for h right here, then our cost will be the equation in terms of r only, right? So cost is equal to 4 times 2, 8 pi r squared plus 4 times 2 again, 8 pi r. H is 32 over pi r squared, right? Eliminate pi, and 1 of the r cancels out. Our cost now is equal to 8 pi r squared plus 8 times 32, that's 256, right? Over r squared, right? I'm sorry, it's just r, because 1 of the r is cancelled out, right? Okay, so we found out our equation of the cost in terms of r, only one variable. Now we're gonna differentiate this equation with respect to r. Okay, so C prime r is equal to, here we have constant a pi times r squared, that's 2r, right? Plus, here that's this part right here, no space, That's 256 times r to the negative 1, right? So derivative of this is negative 256. Negative, if we differentiate this, that's negative 256 r to the power of negative 2, right? That is equal to minus 256 over r squared. So far so good. So we're gonna let this derivative of cost is equal to 0, and we're gonna have to solve for r, right? So 16 pi r is equal to 256 over r squared. So r cubed is equal to 256 over 16 pi, right? Now r cubed is equal to 256 over 16, that's a 16, so 16 over pi. So r is going to be 16 over pi to the power of 1/3, right? And that's the only critical point where c prime is equal to 0. So the cylinder is minimized, the cost of the cylinder is minimized when the radius r is equal to 16 over pi to the power of 1/3.